So I'm Paul Yarin, and I'm a mechanical engineer. I studied at UPenn and Stanford and MIT, and I have a design practice which occupies most of my time. But part of my time I try to spend teaching, doing volunteer work, and so I met Tara and started to structure this curriculum for something we're calling Energy City. Upward Bound, which is a Department of Education funded pre-college booster program for minority kids, or well, basically for low-income kids or people who are the first in their family ever to be able to go to college. And so it gives them a weekly instruction on Saturdays, and then 5 weeks of the year they get to go into college campus and have a taste of the college experience. So this course was structured to serve this particular outfit, the Upward Bound, and it was something new to all of us. Both in terms of the content of the material and the students we'd never met before. So when we prepared the curriculum, it was kind of in the dark, and we were trying to leave it loose enough that we could adapt it to whatever would happen during the session. We had two classes, a morning and afternoon section with 8 hours a week of instruction, and as I said, we built the curriculum from scratch. The students sort of know each other by meeting every week, but they're not necessarily close friends. And you know, part of what happens is that they bond together by spending time in this class. These are just a few photos of students to give you an idea. They're great, you know, enthusiastic, happy kids. We decided to take a particular philosophy to bear on this class, on the construction of this. We wanted something that would be very hands-on and activity-focused, and that would give people the satisfaction of learning by doing. We really did emphasize design and engineering, or the activity of making things, sort of constructivism over scientific theory. And this isn't necessarily what you would do in every situation, but we felt it was appropriate in the context of what we were doing and the resources that we had to work with. So we wanted to come up with an idea which would let me say one more word about the volunteers. So these are the volunteers Tara was mentioning. Some are graduate students, some are you know, working engineer practitioners in the area. All of them donated their time, and you know, were not paid. So the concept was basically to build a model city, which would be a representation of different aspects of energy production and use. So in the United States, at least, we can divide it into the generation of power, into heating and cooling buildings, into lighting, both inside and outside, and transportation, vehicles. There are also other categories that, you know, other ways to look at this, but this was a convenient way to divide the project up. So we also wanted to emphasize documentation. So we had them, when you see the videos in here, they're shot by the students themselves, and you'll see various clippings of writing. While we did it under these particular and somewhat unusual circumstances, we do think that the idea of building an energy city as a class project for various levels is a pretty, it's a useful framework. So, but you know, everybody could adapt it in their own way to their own program. So something to think about as we go through it. Now, one more word about the city. The idea of the city came up because a city is a familiar scale to people. It's, you know, rather than talking about the planet and sort of oceans and other abstractions, we can talk about the use of energy in a very immediate and familiar way. So here are the four sectors that we divided students into, and they basically worked in teams in one of these sort of threads. Power generation, and we'll watch some short video clips. But we did have lessons. We gave a series of lectures of varying length on the main sort of touchstone topics of this. So we talked about what energy is and about converting energy from one form to another, about how to measure efficiency, about the different primary or sources of energy, fossil fuels or renewable sources. And we gave demonstrations of solar panels. There was a popular demo where we connected a solar panel to a windshield washer pump so that you can, in a very visceral way, see you know, how changing the angle of the panel with respect to the sun changes the height of the water that's shooting out of the pump. We taught them how to use multimeters and to measure basic things, voltage, resistance, and you know, circuit continuity. And we had bike dynamos, which were another handy prop that they could use in their projects. Here's a couple of the types of things that the students took it upon themselves to build. And incidentally, we'll come back to talking about more of the assignments in the class, but we'll just give you an idea of the activity. A water wheel. You'll notice that while we did use some kits for demonstration, for the most part, people were making their projects from scratch materials, which we mostly provided. So we would get, and there's pros and cons to that approach, which we can talk about, but you'll see that. And this is in their final presentation for this particular group. They're showing a diorama with their structure here that captures wind in sort of a concave funnel, and has some other, lighting connected to it. I can't remember why there was another wind turbine over there, but there's some argument for it, I suppose. And there's a solar panel. Let's look at another one of the groups. They're basically taking foam core and constructing these little model houses, which they then modify to have different levels of insulation. So we did some experiments about conduction and convection and radiation. And some of the kids, actually, their fathers work in construction, and so they had access to actual fiberglass insulation from houses and so forth, which is an interesting thing that we didn't expect. We showed them how to use an infrared thermometer and to do some empirical measurements. So, I guess this class isn't really a physics class, although there is some physics in it. So we brought in the activities as necessary to inform what they were doing, but we didn't attempt to teach a whole course of physics or of scientific method in this sort of compressed time frame. But again, if we had more time, definitely you could flavor it in whatever way you want for your own students. So that's some fiberglass insulation that he's lining this box with. Incidentally, these pictures are from the USC campus. USC donates the use of their facilities during the summer for this project. This is interesting. He was making a house with clay, kind of like an adobe hut, popsicle sticks and clay. And for example, one of the experiments, we give them an ice cube, and we see whose house keeps the ice cube from melting for the longest under the sun. So you can modify the roof by putting reflective material on it. You can add ventilation to the enclosure. You can paint it and so forth, and you can change the materials on the walls. Let's see. Oh yeah, there's one of the mud houses. In the lighting module, we showed them both different technologies for lighting. More energy efficient lighting, fluorescent lamps versus LED lamps versus incandescent lamps. And we had them use this thing called a kilowatt. It's a little power meter that shows you that you can go around and do an energy audit where you plug in your microwave and your hair dryer and your television, and you see how much current that they're drawing, and you can estimate how much energy you can save by turning them off and so forth. These are just some photos of them building the street lamps. We did actually, in the lighting section, we did some basic circuits. We gave them batteries and motors and fans and switches and lights. We didn't get much beyond that, but basically we showed them basic electronics and at least the notion of completing a circuit and series and parallel wiring. One thing that they did learn is that they can't hook LEDs directly to batteries without some kind of resistor between them to blow them out. These are just some images of, I think that these are street lights. Unfortunately, we don't have photos from the dramatic moment when they lit up the city using the bicycle as a generator, but that was a nice moment in that presentation. One more group. The rolling car was part of their model of cars that would have sails on them. Okay, not a terribly practical idea for most cities, but we wanted to let them explore and do things in a way that they found interesting. We did demonstrations using a really nice kit from Townsend Cosmos, this hydrogen fuel cell car kit, which includes a solar panel, and it lets you electrolyze electrolyze water into hydrogen and oxygen, and save the hydrogen, and then drive the fuel cell and create water and make it move. So that was a nice way for them to get their hands into this, and I recommend this. The workbook is really excellent, great diagrams and images. We also did some, in our early talks about force and motion, we did some projectile motion demonstrations with a tennis ball launching machine. So that's what this thing is over there. And fire it straight up and see how long it takes before it lands again. Try to find the optimal angle and so forth. But again, we didn't have enough time or resources really to get into the full forces and mechanics kind of module. Let's see. So here, these are the core of some cars that they were making. They were modifying some cars, and so here's another notion. These are winged vehicles, again with sails, that travel along this smooth track. And while this is sort of a fantastic notion, there are sail vehicles for sport. They're sort of like windsurfing machines that people use in salt flats in Australia, the desert. So it's not completely the same. This is an air car, which we'll learn more about later. Again, this is something that we're letting them follow their own interest, and they got really excited about personalizing and designing these little vehicles.